A particle located at x is equal to 0 at time t is equal to 0 starts moving along the positive x direction with velocity v that varies as v is equal to alpha root x. The displacement of the particle varies with time as. So what's given here is v is proportional to, not proportional to, v is equal to alpha into root x is what the question says, equal to alpha root x. Now the location is x equal to 0 and the time instant is t is equal to 0. Alright. So we know that velocity, right? Velocity is d by dt of x, right? So if you make use of that equation here, so we have d by dt of x is equal to alpha into root x. So now what I'll do is I'll write root x on the LHS and I'll bring dt towards the RHS. Now let's see. D by dt of t square. Okay, let me write d by dx so that things will become more clear. So d by dx of x square is equal to, or since it's the first video, I'll explain the very basics. So d by dx of x raised to n is equal to n into x to the power n minus 1. So this is the fundamental formula. Okay. Now using this formula, we can write that d by dx of x to the power 2 is equal to 2 into x to the power 2 minus 1, which is equal to 2x. Let me add one more example. So d by dx of x to the power 3 is equal to 3 into x to the power 3 minus 1, which is equal to 3 into x square. Now, what is root x in terms of exponent? Say root x is basically equal to the x to the power 1 by 2. Okay. So we can write that d by dx of x to the power 1 by 2 is equal to 1 by 2 into x raised to 1 by 2 minus 1, which is equal to 1 by 2 into x to the power minus 1 by 2. Now see, x raised to n is equal to 1 by x raised to minus n. Another example, x raised to minus n is equal to 1 by x raised to n. So if you bring this logic here, what is this? 1 by 2 into x raised to minus 1 by 2 is x raised to 1 by 2. And what is x raised to 1 by 2? It is root x. So this becomes 1 by 2 into 1 by root x, which means d by dx of root x is equal to 1 by 2 root x. So in order to solve this question, what I'll do is I'll multiply this whole equation by 1, and I'll write 1 as 2 by 2 into dx by root x is equal to alpha dt. So what do we get here? I'll write 2 separately. So I'll write this 2 separately into 1 by 2 and then dx by root x is equal to alpha dt. Now what we can do is we can integrate on both sides. So what we get is 2 into integral of 1 by 2 root. See, if d by dx of root x is 1 by 2 root x, what is integral of 1 by 2 root x dx is equal to? It will be equal to root x. So this whole LHS becomes 2 into root x is equal to alpha into, see, d by dt of t is equal to 1 implies integral of 1 dt is equal to t. So this will become alpha into t. Therefore, we get the relation as 2 root x is equal to alpha t. And it is this relation what we call as the position time relation. So let us express this in terms of x rather than root x. So if root x is proportional to t from this equation, if we can square on both sides, so this becomes root x the whole square is proportional to t square. What is root x the whole square? It is root x into root x is proportional to t square. So root x and root x is x. So x is proportional to t square, which means the correct option is t to the power 2, option B. The coordinate of a moving particle at time t is given by x equal to ct cube and y is equal to bt cube. The speed of the particle is. Okay, so before I start explaining this question, though this is based on calculus, I do admit it, but what I would like to explain you further is the concept of resolution of forces. See, any force F can be resolved, which is acting at an angle theta, can be resolved into two components, which is Fx and Fy. Components such that Fy is perpendicular to Fx, which means the angle between them is 90 degree. Okay. In this case, the magnitude of F, the resultant vector F, is basically given by root of Fx square plus Fy square. So we need to understand this particular concept. I'll repeat it once again. We have a vector F which can be resolved in two different components, Fx and Fy. Or in other words, we can say that F can be written as the resultant of Fx and Fy, in which case the magnitude of the resultant vector F or the magnitude of the original vector F is given by root of Fx square plus Fy square. Alright, so now you might be asking, why am I explaining this concept here? I'll tell you why. Because the explanation goes like this. See, x is given to be ct cube and y is given to be bt cube. Alright, now what we'll do is we'll find out velocity with respect to x and velocity with respect to y. So what will be Vx? Vx will be equal to d by dt of x, alright, and Vy will be equal to d by dt of y, which is equal to, I'll eliminate it here, which is equal to d by dt of x. What is x? X is ct cube, I put it in a bracket, and Vy is equal to d by dt of y. What is y? Y is bt cube, right? Moving on further, since c is a constant, I can take c outside, so what I get is c into d by dt of t cube, which is Vx, and Vy is equal to, take b common, and what do I get? d by dt of t cube. Now, what is d by dt of t to the power n? It is n into t to the power n minus 1. In which case, what is d by dt of t cube? It is 3 into t to the power 3 minus 1, which is basically equal to 3 into t square, right? So I can write here Vx is equal to c into 3t square and Vy is equal to b into 3t square. Alright. In which case, let us bring in this formula now. So what is V is equal to? V is equal to root of Vx square plus Vy square, wherein Vx is equal to root of, what is Vx? Vx is 3t square c the whole square plus what is Vy? Vy is 3t square b the whole square, which can further be written as root of 9 t raised to 4 c square plus 9 t raised to 4 b square. So v can be written as root of, now what I'll do is I'll take 9 t to the power 4 is common. This becomes into c square plus b square. And further, v will be equal to, now what we'll do is I'll split the product. So I'll write as 9 t raised to 4 into root of c square plus b square. I'll split the product further, root of 9 into root of t square into root of c square plus b square, and therefore v is equal to root 9 is 3, root of t square is t into root of c square plus b square. Alright, so what is the correct option? The correct option here would be 3d square, which is option B. A particle moves a distance x in time t according, it's not according to the equation, it's according to the equation x equal to t plus 5 the whole raised to minus 1. The acceleration of the particle is proportional to. So before I start explaining you the concept behind this, the solution, let me explain the concept behind. So what we have is x equal to t plus 5 the whole raised to minus 1. Let me take you through examples like that. So let's say y is equal to x raised to minus 1, in which case what is dy by dx is equal to, it will be equal to d by dx of x to the power minus 1, and we know that d by dx of x raised to n is equal to n into x raised to n minus 1. So d by dx of x to the power minus 1 will be equal to minus 1 into, right, x raised to n minus 1. What is n here? Minus 1. So this becomes minus 1, which is equal to minus 1 x to the power minus 2, right? Now see, x to the power n can be written as 1 by x to the power minus n. X to the power minus n can be written as 1 by x to the power plus n, which means this I can write it as minus 1 by x to the power plus 2, which makes d by dx of x to the power minus 1 is equal to minus 1 by x square. I hope this much is clear. Now, we need understanding about the, okay, I think we can solve the question with this much, but okay, let's go one step further. So keeping this example in mind, let us solve another equation which says y is equal to say x plus 3 the whole to the power minus 1, in which case dy by dx will be equal to, say, d by dx of x plus 3 the whole time minus 1, which is equal to n into, right, because d by dx of, write it once again, so d by dx of x to the power n is equal to n into x to the power n minus 1. So what is n here? Minus 1. What is x here? We don't have x here. Instead of x, we have x plus 3, which is equal to x plus 3 into x plus 3 raised to minus 1 minus 1. Now, since it is not just x and x plus 3, what we need to do is we need to multiply into d by dx of x plus 3. So this is what we have to do. Okay. So this will become minus 1 into x plus 3 the whole power minus 2 into, what is d by dx of x plus 3? It is 1 plus 0. Therefore, this becomes minus 1 by x plus 3 whole square. Therefore, we can say that d by dx of x plus 3 the whole raised to minus 1 is equal to minus 1 by x plus 3 the whole square. Alright, we're not done yet. Keeping this in mind, we'll solve one more derivative. So let's say we have y is equal to x plus 3 the whole to the power, okay, let's say x square plus 3 the whole raised to the power minus 1, in which case we know that dy by dx will be equal to d by dx of x square plus 3 whole to the power minus 1, but we know that d by dx of x to the power n is equal to n into x to the power n minus 1. Here n is equal to minus 1, which will change the equation as dy by dx is equal to minus 1 into x square plus 3 the whole to the power minus 1 into, what did we say, into d by dx of what is inside here is x square plus 3. So this gives us the answer minus 1. Okay, so this is not minus 1, this is minus 1 by x square plus 3 to the power plus 2 into what is derivative of x square? It is 2x. What is derivative of 3? It is 0. So this becomes minus 2x the whole upon x square plus 3 the whole square. So we can say that d by dx of x square plus 3 the whole to the whole power minus 1 is equal to minus 2x by x square plus 3 the whole square. So please watch this this a couple of times, right from the first example to the third one. I hope I have given you the clarity. If you have done listening to the explanation a couple of times, let us start solving this question specifically. So what is given here? Given that x is equal to t plus 5 to the power minus 1. So we know that dx by dt would be equal to, or d by dt of x would be equal to d by dt of t plus 5 the whole to the power minus 1, which is again d by dx of x raised to n will be equal to n into, right, d by dx of x raised to n will be equal to n into x to the power n minus 1. Instead of x we have t plus 5 here, instead of n we have minus 1 here. So this will give you minus 1 into t plus 5 times t plus 1 the whole raised to minus 1 into dt by d by dt of t plus 5, which is 1 plus 0. So this further becomes minus 1 by t plus 5 the whole square. So dx by dt is equal to minus 1 by t plus 5 the whole square. Now what is dx by dt? We know that velocity is equal to dx by dt, and it is minus 1 by t plus 5 the whole square. All right. Okay. So now we are not asked to find out velocity. What we are asked to find out is the magnitude of acceleration and the relationship between acceleration. Okay. So what is acceleration now? See, acceleration is basically dv by dt, or which otherwise would mean d by dt of v. And what is v? V is velocity. What is velocity? Velocity is minus 1 by t plus 5 the whole square. So this will be equal to d by dt of, I can take minus 1 outside here, d by dt of t plus 5 the whole raised to minus 2, right, which will be equal to minus 1 into n into, what is n here? Minus 2. Instead of x we have t plus 5 the whole raised to n minus 1, which is minus 2 minus 1. This will give you minus 1 into minus 1 is plus 2 into t plus 5 the whole raised to minus 3, which otherwise can be written as 2 by t plus 5 the whole raised to 3. So acceleration is equal to 2 by t plus 5 raised to 3. Now let us try to find out the relationship between these values. Okay, so what we can write is acceleration is 2 into t plus 5 the whole raised to minus 3. See, what I'll do is I'll make a small algebraic manipulation here. How? I'll write 3. See, what is minus 3? Minus 3 can be written as minus 3 into 1, or minus 3 can be written as 1, which is 2 by 2, right? Or minus 3 can also be written as minus 3 into n by n, or can be written as minus 3 into 4 by 4. So minus 3 can be written as any minus 3 into any number by that number. Alright. Now here what I'll do is I'll take minus 3 as minus 3 into 2 by 2. Why? I'll tell you now. So I've taken minus 3 as minus 3 as minus 3. Okay, let me write like this. Minus 3 into 2 by 2. Okay. Now I'll write this further as 2t plus 5 the whole times into raised to minus 3 by 2 into 2. Just basic change of fraction. It remains the same. The value remains the same. Further, let's have a look at t plus 5 raised to minus 3 by 2. If you see what is t plus 5 the whole raised to minus 3 by 22, I'll write it further again. T plus 5 the whole raised to 2, or let us say t plus 5 the whole raised to t plus 5 the whole raised to minus 2 into 3 by 2. All right. Now see, what is velocity? Velocity is equal to minus 1 into t plus 5 whole to the power minus 2. So what is t plus 5? T plus 5 will be v by minus 1 is equal to t plus 5 whole to the power minus 2. So instead of t plus 5 to the power minus 2, what can I write here? I can write this as 2 into minus v whole to the power 3 by 2, which is equal to a. All right. Now, see, in this equation, 2 is a constant. So all what varies is acceleration is proportional to velocity to the power 3 by 2. Which means, are we done with the option? Yes, the correct option is velocity to the power 3 by 2. A particle moves along the x-axis as x is equal to 4 into t minus 2 plus a into t minus 2 the whole square. Which of the following statements are true? The initial velocity of the particle is 4. The acceleration, the particle is at origin at t is equal to 0. Okay, all right. So this is a typical application of differentiation. Let's see. So what's given is x is equal to 4 into t minus 2 plus a into t minus 2 the whole square. In which case, what is velocity is equal to? This will be equal to d by dt of x, which is equal to d by dt of 4 into t minus 2 plus d by dt of a into t minus 2 the whole square. So v can be written as 4 into d by dt of t minus 2 plus a into d by dt of t minus 2 the whole square. So this implies 4 into d by dt of t minus d by dt of 2 plus a into d by dt, okay, plus a into 2 into t minus 2 into 2 minus 1 into d by dt of t minus 2. So yes, I do understand you may have doubt here. So I'll elaborate that point. So what I've done is, see, d by dt of t square is 2 into t into 2 minus 1, which is equal to 2 into t raised to 1. Now d by dt of t minus a the whole square will be equal to 2 into t minus a the whole raised to t minus 2 minus 1 into d by dt of t minus a. Very similarly, d by dt of t minus c the whole cube will be equal to 3 into t minus c the whole raised to 3 minus 1 into d by dt of t minus c. Okay, so similarly I have taken the logic here, t minus 2 the whole square, 2 into t minus 2 the whole raised to 2 minus 1 into d by dt of t minus 2. So this further becomes v is equal to 4 into what is d by dt of t? It is 1 minus what is d by dt of 2? It is 0 plus that's 2a into t minus 2 the whole raised to 2 minus 1 is 1 into d by dt of t minus 2 is, we just find out, 1 minus 0. So v is equal to 4 plus 2a into t minus 2. Therefore v is equal to 4 plus 2at minus 4a. Alright. So now let's write down the given equations once again. So we have x is equal to 4 into t minus 2 plus a into t minus 2 the whole square. So there is one option which says particle is at origin at t is equal to 0. So what is the value of x when t is equal to 0? It is equal to 4 into 0 minus 2 plus a into 0 minus 2 the whole square. So x at t is equal to 0 is equal to 4 into 0 minus 2 is minus 2 plus a into 0 minus 2 is minus 2 whole square. So what we get is minus 8 plus 4a. So we have x at t is equal to 0 is minus 8 plus 4a, which is definitely not equal to 0, in which case we can say that particle is not at origin at t is equal to 0. So we have ruled out that point. Now the second point is initial velocity of the particle is 4 units. Okay, so let's find out that too. So since v is equal to 4 plus 280 minus 4a, we can find out v at t is equal to 0, which is actually the initial velocity is equal to 4 plus 2a into 0 minus 4a. So v at t is equal to 0 is equal to 4 minus 4a. So that option is also wrong. So now let's see, the acceleration of the particle is 2a. Okay, so since we have v is equal to 4 plus 280 minus 4a, what is a is equal to? A is dv by dt or d by dt of v, which is equal to d by dt of 4 plus 2a into d by dt of t minus d by dt of 4a. So a is equal to d by dt of 4 is 0 plus 2a into d by dt of 1 is d by dt of t is 1 minus d by dt of 4a is 0. So what you get is a is equal to 2a. Now what does the option says? Yes, A says that the acceleration of the particle is 2a. Therefore, the correct option is option B. The x and y coordinates of a it's not partial, it's particle. It's particle. At any time t is given by x is equal to 7t plus 4t square and y is equal to 5t, where x and y are in meter and time. X and y are in meter and time is in seconds. The acceleration of the particle at t is equal to 5 seconds. Is. So we did a similar question. Let's try to solve this based on the same logic. So x is given to be 7t plus 4t square and y is given to be 5t. So we know that v is equal to dx or d by dt of x, which is equal to d by dt of 7t plus d by dt of 4t square. Similarly, excuse me. Similarly, okay, let me write this as Vx is equal to. Similarly, Vy is equal to d by dt of y, which is equal to d by dt of what is y? Y is 5t. So what is Vx is equal to? Vx is equal to, since 7 is a constant, I can take 7 outside, so that becomes 7 into d by dt of t plus 4 into d by dt of t square. Now what is Vy? Vy is equal to 5 into d by dt of t. Now what is d by dt of t raised to n? It is equal to n into t raised to n minus 1. In which case, what do we get here? Vx is equal to 7 into, this is t raised to 1. So 1 into t raised to 1 minus 1 plus 4 into t raised to 2. So 2 into t raised to 2 minus 1. Similarly, Vy is equal to 5 into t raised to 1. So 1 into t raised to 1 minus 1. So Vx is equal to 7 into 1 into t raised to 0 plus 4 into 2 is 8. T raised to 2 minus 1 is t raised to 1. Similarly, Vy is equal to 5 into 1 is 5. T raised to 1 minus 1 is t raised to 0. Now we know that anything raised to 0 is equal to 1. So Vx will get it as 7 plus 8t and Vy will get it as 5. Now the question is to find the acceleration. So let's write down Vx and Vy again. So we have Vx is equal to 7 plus 8t and Vy is equal to 5. Now what is Ax? Ax is equal to d by dt of Vx. And what is Ay? Ay is equal to d by dt of Vy. In which case Ax is equal to d by dt of 7 plus 80 and Ay is equal to d by dt of 5. So Ax will be d by dt of 7 plus 8 into d by dt of 8. Sorry, d by dt of t. And Ay will be equal to 0 because 5 is a constant. So what do we get here? Ax is equal to, this value will become 0 plus 8 into 1 and Ay is equal to 0. Now what is A is equal to? A will be root of Ax square plus Ay square, which is equal to root of 8 square plus 0 square, which is equal to 8, and therefore the answer is option B. The displacement of a particle moving in a straight line depends upon time t, as x is equal to at cube plus bt square plus ct plus d. The ratio of its initial acceleration to its initial velocity depends upon. Okay, so again, a very simple question regarding differentiation. So we have x is equal to at cube plus bt square plus ct plus d. So we know that v is equal to dx by dt or d by dt of x, which is equal to d by dt of at cube plus d by dt of bt square plus d by dt of ct plus d by dt of d. So v is further equal to a into d by dt of t cube plus b into d by dt of t square plus c into d by dt of t plus d by dt of d. So what we should understand here is that a, b, c and d are constants. That's point number 1. Point number 2. d by dt of t raised to n is equal to n into t raised to n minus 1. Alright. So if we apply these two, so we get a into 3 into t raised to 3 minus 1 plus b into 2 raised t b into 2 into t raised to 2 minus 1 plus c into 1 into t raised to 1 minus 1 plus 0, because derivative of a constant is 0. So v becomes a into 3 into t square plus b into t raised to 1 plus c into t raised to 0 plus 0. So this can otherwise be written as v is equal to 3a t square plus 2bt plus t raised to 0 is 1, so that becomes c. So we have an expression for v. So let me write it down once again. v is equal to 3a t square plus 2bt plus c. Now what is a is equal to? Acceleration is rate of change of velocity, which is d by dt of v, which is further equal to d by dt of 3at square plus d by dt of 2bt plus d by dt of c. So acceleration is equal to 3a into d by dt of t square plus 2b into d by dt of t plus d by dt of c. So acceleration will be equal to 3a into 2 into t raised to 2 minus 1 plus 2 into b into 1 into t raised to 1 minus 1 plus 0, and a is equal to 6a into t plus 2b. So this is what we have the expressions for a and b. Now the question is not to find the expression for a and b, expression for v and a. It is to find out the ratio of initial acceleration and initial velocity. So v initial will be now equal to, right? So v initial will be equal to v at t is equal to 0, which means 3a into 0 plus 2b into 0 plus c, and acceleration at t is equal to 0 will be equal to 6a into 0 plus 2b. So we can write that initial acceleration, right? So we can write that required ratio is a at t is equal to 0 upon v at t is equal to 0 is equal to 2b upon, so this is 0, this term is also 0, 2b upon c, which means this ratio is dependent only on b and c, and therefore the correct option is option C. The motion of a particle along x-axis is given by the equation s is equal to 9 plus 5t square, where s is the distance in centimeter and t is the time in seconds. Average velocity during the interval from t is equal to 4 seconds to t is equal to 7 seconds is. So what is given is the distance time relationship, which is s is equal to 9 plus 5t. What is the velocity? Velocity would be equal to d by dt of s, which is equal to d by dt of 9 plus 5 into d by dt of t square. Now let me clarify the differentiation again. So what is d by dt of t raised to n? It is equal to n into t to the power n minus 1. So what is what is d by dt of a constant? D by dt of a constant k is equal to 0. In which case what we have here is d by dt of 9 is a constant, which is 0, plus 5 into what is d by dt of t square? From here is n into t to the power. So n on the place of n we have 2 into t to the power n minus 1. Here this becomes 2 minus 1. So this is equal to 5 into 2 is 10 into t raised to 2 minus 1, which is 10t. So velocity is equal to 10 into t. Now, if velocity is equal to 10 into t, what is velocity? What is velocity at t is equal to 4? It is 10 into t is equal to 4. Simple, right? And what is velocity at t is equal to 7? Velocity at t is equal to 7 is equal to 10 into t is equal to 7, right? Now what is 10 into t equal to 4 implies? 10 into 4, which is equal to 40. And what is t to 7 implies? 10 into 7, which is equal to 70. Now what is that we need to ask to find out? Average velocity. So average velocity, v average here will be equal to v1 plus v2 by 2, which is equal to 10 plus 70 by 2, which is equal to 110 by 2, which is 55 kilometers. So v average here is equal to 55, not kilometer per hour, is equal to centimeter per second, which marks the correct answer as option B. So this is our final answer, 55 centimeter per second. A particle is projected with velocity v0 along x-axis. The deceleration of the particle is proportional to the square of the distance from the origin. The distance at which the particle stops is equal to. Alright, so now I think we are moving to a slightly higher level of difficulty in doing the questions. Usually these kind of questions are asked only for entrance exams which are not at the advanced level. Okay, anyway, let's set aside the difficulty level and start solving the question. So let us assume that what's given, the deceleration what is proportional to the square. Okay, so what's given is deceleration, right, which is say a, is proportional to the square of the distance. So this will further be equal to, further be a is equal to minus k into x square. Okay, in which case I may have to alter the option here. So let's take that every option here is 3v0 by not 2a. Let us assume that to be 2k. Okay. So if a is equal to minus k square, see what is basically a is equal to? A is acceleration, which is equal to rate of change of velocity dv by dt, which means I can write here that dv by dt is equal to minus kx square minus kx square, in which case what is dv is equal to? Dv is equal to minus kx square into dt, right? Now, so dv, what is dv is equal to? See, what is v? V is velocity, and what is velocity is equal to? Velocity is equal to dx by dt. Okay, so we are going to, what we're going to do is we're going to do a small rearrangement here. And how will it look like? I'll tell you. See, we have written here dv is equal to minus kx square into dt. Okay, further what I'll write is I'll divide here by dx and multiply it by dx, in which case dx by dx is 1, right? So that concept remains simple. Dx by dx is 1, and then we have dt here, which means we'll be back to the same equation. All right. Further, I'll write dv is equal to minus kx square. Now have a look at what we've done here. See, what is dt by dx? From here, dx by dt, see, v is equal to dx by dt, in which case what is the reciprocal? Dt by dx will be equal to 1 by v. Simple. So I'll bring in this 1 by v here. So I'll write this as 1 by v into dx. Taking this derivation further, I can write that dv is equal to minus kx square into dx, and this time I'll bring this v to the LHS. So we have v dv is equal to minus kx square into dx. All right. Now I'll rewrite this equation again. Okay, we don't need this part now. So I'll rewrite this equation again, which is v dv is equal to minus kx square times dx. Now what I'll do is I'll integrate on both sides. But while integrating, we need to know the limits. So we need to know the limits of velocity as well as the displacement. See, it is given that a particle is projected with velocity v0, right? The deceleration of the particle is proportional to the square of the distance. Now, when the particle is projected with velocity v0 and it is decelerating, we know that at some point of time, the maximum, so the deceleration will cause the velocity to become 0, which means the initial limit of velocity will be, the initial value of velocity will be v0, and it will eventually reach 0. Now, what will happen to displacement? See, displacement, we know that we have to find out the corresponding displacement with respect to v0 and 0, that is final and initial. Now, when the body has started moving, the velocity was v0, and since the motion has just begun, the displacement would be 0. And when the body has attained zero velocity, which means it has undergone deceleration, which means it has undergone some motion, let us say the final displacement be equal to, is there any values, any alphabet specified here? No, let us say the displacement is equal to s. Okay, so I repeat, the initial velocity was v0, the motion has not begun, the displacement is 0. The final velocity, the body came to rest, in which case it has moved some distance which I call it as s. So if I rewrite this equation here, right, if I rewrite this equation here, what can I write the limit as? I can write the limit as v0 varying from, v varying from v0 to s, and displacement is varying from 0 to s, displacement varying from 0 to s. Now I'll do the integration. What is v dv? See, okay, I'll explain that also. See, integral of x to the power n dx is equal to x raised to n plus 1 the whole upon n plus 1, which means this here will be v raised to n plus 1. What is n here? 1. So this is v raised to 1 plus 1 the whole upon 1 plus 1. Limit varying from, what is the lower limit? The lower limit is v0, and what is the upper limit? It is equal to s, is equal to minus k is a constant here, right? And what is the integral of x square by this formula? X square dx will be equal to x raised to 2 plus 1 the whole upon 2 plus 1, which is equal to x raised to 3 whole upon 3, and the limit varying here from 0 to s. Okay, now let us apply the upper limit minus lower limit, which goes like this. If you write one more step here, this becomes v square by 2 limit varying from v0 to s is equal to minus k into limit varying from, okay, that doesn't make much difference here. It becomes minus x cube into x cube by 3 varying from 0 to s. Okay, not v0 to 0, right? Okay, I made a mistake. It's not v0 to s, it is v0 to 0. All right. Now, what happens when you apply the limit? What we get is upper limit minus lower limit. So it becomes 0 square by 2 minus v0 square by 2 is equal to minus k into s cube by 3 minus 0 cube by 3, which further becomes minus v0 square by 2 is equal to minus k into s cube by 3. So what is that we are asked to find out? We are asked to find out the distance or the displacement here. So we need to express this whole equation in terms of s. So what I'll do is I'll take 3 to the other side. Minus and minus cancel. So we get 3 by 2 into v0 square the whole upon k is equal to s cube. All right. So let me write it once again. So s cube is equal to 3 by 2 v0 square by k. Okay, 3 v0 square by 2 by 2k is what we are looking in the option. Okay, 2k. And since it is s cube, if we take 1 by 3 on both sides, so let me write down that also. So we have 3 v0 square by 2 the whole upon 2k. Now what I'm going to do is I'm going to take the power of 1 by 3 on both sides, the whole raised to 1 by 3. What will happen to the LHS? See, 3 into 1 by 3 becomes 1. So we get S is equal to 3 v0 square by 2k the whole upon 1 by 3, which makes the correct option as option 3 v0 square by 2k, option T. The displacement of a particle varies with time as t as x is equal to a e raised to minus alpha t plus b e raised to beta t, where a, b, alpha and beta are constants. The velocity of the particle will be independent of alpha and beta, go on increasing with time, drop to 0 when alpha is equal to beta, go on decreasing with time. Okay. So let us first write the given equation, which is given as x is equal to a into e raised to minus alpha t plus b into e raised to beta t. Let me first differentiate both sides with respect to x. x. So with respect to t, so what we get is d by dt of x is equal to a into d by dt of e raised to minus alpha t plus b into d by dt of e raised to beta t. Now let me also write down the derivative of e raised to x. So see, d by dx of e raised to x is equal to e raised to x. It's very simple. Now, what is d by dx of e raised to 2x? It is equal to e raised to 2x into d by dx of 2x, which is e raised to 2x into 2, or 2 e raised to 2x. Similarly, what is d by dx of e raised to 3x? It is equal to e raised to 3x into d by dx of 3x, which is equal to 3 e raised to 3x. One more, d by dx of e raised to minus 1x is equal to e raised to minus 1x into d by dx of minus 1x, which is equal to minus 1 into e raised to minus 1x. Right? So these 4 examples are enough to solve this question. So the answer goes like this: dx by dt, which is equal to v, is equal to a into, use this logic here, what is d by dt of e raised to minus alpha t? Minus alpha into e raised to minus alpha t, right? Minus 1x minus alpha. My d by dx of, okay, I think I should write that in detail. Okay, so d by dx by dt, that is v, is equal to a into, what is d by dt of e raised to minus alpha t? It is e raised to minus alpha t into d by dt of minus alpha t plus b into, what is d by dt of e raised to bt? It is e raised to bt into d by dt of bt. Now v is further equal to a into e raised to minus alpha t. What is d by dt of minus alpha t? It is minus alpha into d by dt of t plus b into e raised to beta t into, what is d by dt of beta t? Is b into d by dt of t, right? So this becomes v is equal to minus alpha into a e raised to minus alpha t plus d by dt of t is 1 plus beta into e raised to beta t. All right. So what I'll do is I'll write the positive fraction first. So positive term first. So beta v is equal to beta into e raised to beta t minus alpha into, oh, I'm sorry, I skipped b here, right? B here. Okay. So minus alpha into, so this is b into beta into e raised to beta t. Okay. Minus alpha into a into e raised to minus alpha t. All right. So in order to find out the correct option, I will write down this relation once again, or maybe I'll write it 2 times. So we have v is equal to b into beta into e raised to beta t minus a into alpha into e raised to minus alpha t. Okay, so I'll write this one more time. Okay, now let us try to understand the options. See, we know that as x is positive, e raised to x is also positive, right? Or we can say this other ways. If x is increasing, right, for the value of x is increasing, e raised to x also increases. And as x is increasing, what happens to e raised to minus x? E raised to minus x now decreases. Okay, so it's very simple logic. So as the value of x increases, we can say that e raised to x increases, and at the same time e raised to minus x will decrease. Okay. Okay. Now let us apply this concept here. So here instead of s we have, so we can say that as t increases, e raised to beta t will increase and e raised to minus alpha t will decrease, right? So let me highlight this. So as t increases, e raised to beta t increases, whereas e raised to minus alpha t will decrease. Let us now further try to understand this, which means, say when we, okay, when t is equal to 1, v will be equal to b into beta into e raised to beta minus a into alpha into e raised to minus alpha, because t is 1, right? T is 1. Similarly, when t is equal to say 10, this will be equal to b into beta into e raised to 10 beta minus a into alpha into e raised to minus 10 alpha. Let us take one more example. Say v t is equal to 100 is equal to b into beta into e raised to 100 beta minus a into alpha into e raised to minus 100 alpha. Now, see, let us now try to understand what is the physical meaning of this. This means that v at t is equal to 1 is basically equal to b into e raised to beta. E raised to beta is a larger quantity, so this is a large number, minus e raised to minus alpha t, because the value decreases, minus a small number, right? Which, say for example, I would take 10 minus 1 is equal to 9 is basically a large number, right? I can further give an example for the second case. When vt is equal to 10, e raised to 10 beta is basically a very large number, right? Exponential power to the 10 minus e raised to minus 10 alpha. We know that e raised to minus 10 alpha, the value decreases. So this will be a very small number. And when this is a very small number, a very large number minus a very small number, say 1000 minus 0.1 will again be a very small number. So this will give you a very small number. Let us go one step further. When t is equal to 100 means we get e raised to 100 times beta, which means exponential power to the 100. This will be a, say for example, a very large number minus a very small number, which, say for example, would give you minus 0.0000000001, which is again a very large number. So this here will be equal to a very large number. Now look at the progression. So as t increases, velocity was large, it was I'm sorry, did I write small here? So sorry, this is large. So it will be very large, and then it become very large, which means as t increases, velocity increases. Okay. So that marks the conclusion. So which means the velocity of the particle will keep on increasing with time.